Taking a closer look at the LJ Create Electric Vehicle Charging Stations Panel Trainer. Our electric vehicle charging stations trainer is designed for safe investigation of the following. Number 1. The operation of the charging station circuits for DC and AC charging. Number 2. Control signals linking vehicle and charging station, and what happens to halt the charging when these signals are interrupted. Number 3. Troubleshooting the charging station and in-car charging circuits.
Taking a closer look at the operation of the charging station circuits for DC and AC charging.
The Electric Vehicle Charging Stations trainer teaches students about the different modes of operation of both an AC and a DC charging station. The panel represents a charging station which can be switched between AC charging and DC charging. Plus the in-car charging system and an HV battery stack to illustrate the effects of charging. The panel can also be connected to our EV systems panel and our EV batteries panel, and can be used to charge both of these. A touchscreen LCD panel is used to configure and monitor the operation of the charging station, and to monitor the result of the charging for the in-car section of the trainer. Isolated pins are distributed across the front of the panel, so that students can measure voltage levels or monitor waveforms. The energy journey on the trainer begins with a 240-volt, three-phase input, as would be provided by the national grid. This supply feeds both a DC supply circuit and an AC supply circuit, which switches between single and three-phase charging.
Taking a closer look at the control signals linking vehicle and charging station.
The panel is divided into 3 sections. The first section is the onboard vehicle section. This block contains all the functional systems that are found on an electric vehicle, including the high-voltage battery stack and battery management system, the HV distribution contactors, auxiliary battery, the charge controller and an onboard AC charger. The BMS and charge controllers communicate with each other using CAN signals which can be monitored and analyzed. A second section represents the DC charging circuits. These comprise an AC to DC converter, a DC to DC converter, and various drivers, feedback, and management systems. The third section illustrates the blocks required to transmit the AC supply to the vehicle, including the management system for the electric vehicle supply equipment. This block generates the control signals that link charging station and vehicle. Rotary controls on the trainer allow the user to modify HV battery temperature and charge levels, to switch between the 2 LCD display modes and to select different charging scenarios. The 5 charging scenarios are: onboard DC charging, onboard AC charging, charging disconnect or reset, DC charging when connected to another of the EV panel range, AC charging when connected to another EV panel. Students can select onboard AC charging and select the single-phase option, situated to the left of the residual current device and AC charging contactors. The indicator beneath the AC charging connector lights up to show that the contactors are closed. The LCD display illustrates the connection between charging station and vehicle, and it shows the current level of HV battery charge. Press the start button and the onboard vehicle block closes the HV distribution contactors and the vehicle AC charger contactors. Current is fed from a single AC line, through the charge ports and into the vehicle AC charger. The LCD display indicates the rate of power delivery at 7 kilowatts, the cost, total energy transferred and time elapsed. Switching the input to 3-phase increases power delivery to 22 kilowatts. Students can select vehicle mode on the LCD display, and we can reduce the temperature of the battery down below minimum operating levels. At which point the vehicle sends a signal back to the EVSE and causes the charging station to stop sending current. After resetting the panel, students can select onboard DC charging. This will illuminate the DC charging contactor, showing that these contactors have closed. If the HV battery voltage level is reduced, and the start button pressed, the DC charging sequence is initiated. Students can see from the LCD panel that the vehicle is now charging at 52 kilowatts, and can monitor the associated cost. The panel can be configured for different geographic regions.
Taking a closer look at troubleshooting the charging station and in-car charging circuits.
As with other panels in the LJ Create range, one of the primary functions of this trainer is to provide practice with troubleshooting. This panel will illustrate probable causes of charging faults, to help train EV technicians of the future. Instructors have a passcode to open the fault insertion panel. 16 faults are available, covering all blocks of the charging station system. The fault insertion panel provides optional descriptions of each fault. Multiple faults can be inserted at the same time. Learners may require a multimeter or scope to confirm the faulty component. If the charging station's panel is connected to another in the range, in this case the EV systems panel, students can see what happens at the charging station if the electric vehicle develops a fault during charging, or vice versa. Following a period of learner practice, instructors can insert a number of faults, lock the insertion panel, then leave the learner to list out the faulty components as an authentic assessment activity. If you have received your panel, we're here to help you integrate it into your program. If you would like to order a panel, please contact us for more information.